Hello, welcome to the Bootstrapping the Golang application talk. So, yeah, well, we are working as well, like in some cool company, like we do the outreach, that's the kind of sales execution platform, which I personally don't understand, but like it has a really nice engineering challenges. So there is always some like food for your brain as well. So let me introduce myself first. I'm Pavel Šmejkal, and I'm the engineer in the ECS team, which handles the email and calendar ingestion for the whole outreach platform, which is kind of like backbone, pretty much like for 50%, let's say, of the backbone for the whole outreach traffic. And I worked with Golang for 9 years, and like before outreach, I spent like quite some time in Microsoft Skype. Luckily, I was like working with Go and Amazon AWS like back then, so I'm not that spoiled. Okay, so this talk is about pretty much things that every time you do something new, you actually need. And I just like want to set up the stage a little bit first. So like what the developers actually are doing every day. So first of all, like we want to make some application, right? So usually it's easy on some like from the functional point of view, usually it's easy. But then it kind of makes it more complicated. We like design stuff, right? And we want to follow like noble principles like the solid and we do composition, and there are so many architectures. So let's use this one or this one. Like we are trying to be closer to hexagon one, for example, and so on, which adds complexity, which simplifies some stuff, but makes the other stuff more complex. Then we seek for the resilience in our application because, like, we are living in kind of fluent world. Nothing is ideal, especially network and so on. So we put like more things and more stuff into our application, which actually makes it even more complex, like retry logic, circuit breakers, you name it, tracing layers, telemetry and stuff. And then we do fight as well for kind of resources because like our employers needs burn money for us and so on and so forth. So we again want to either keep resourcing low or just like we want to protect ourselves from like busy users. So like we put there like different thread pools and async processing and all of that stuff, right? So we have many layers that acts different kind of purposes, pretty much serves different purposes. And then once we have all this ecosystem, we just have to write a test for each thing because like we want to be safe, right? So that's what we do. Usually turning coffee into some code and so on. So how the kind of standard application might look like, right? So you have usually in the center some like domain logic, and then like on the edges some adapters that kind of either allows you to communicate with outer world, HTTP, GraphQL, gRPC, whatever you name it. And we have some persisting storage that allows us to remember things that we would lose normally, right? And then we have some async processing that helps again, like with resiliency and throughput and so on. So that's kind of like naive, simple application, right? But it's usually not like this, especially what I mentioned, like what we like, right? So we kind of complicate stuff. We put the layers on top of the layers because like we like to work with Go, and Go usually has some just composition. So let's compose the stuff. So you compose the stuff and we build up the onion and so on and so forth. So we make the final graph quite complex. And then like, okay, like we need to build it somehow. We have to stitch it all together, right? And it's usually difficult. So there is like another point of view as well. So we have these like layers which kind of brings the behavior and so on and so forth. But there are not just these like horizontal towers of everything, but like we have as well communication between these components. So we in this small example, right? We have again a simple application, some kind of the RPC server or HTTP server that kind of again communicates with the outer world. We have some services that requires to have some dependencies, and we have like the red ones are sort of like stateful, the green ones are kind of stateless. and we have as well some other service to call. So it kind of like inflow from beginning to the end, to the storage, whatever, right? And this is just the hierarchy. But on the other hand, you might look at the same picture from very like different angle. All these components that are like stitched together using these layers are communicating between each other, and there is like a semantic order that when you're building up and bootstrapping the application, you need to kind of preserve. Otherwise, you have to deal with like many problems. And like I'm glad that like in previous actual talks, it was mentioned as well partially, and the solution might help with a couple of these problems as well. So imagine that you are building this application, right? You have to sort of build up the tree in a certain order to actually make it all work, because usually the application is covered by a load balancer, which has like, you need to report the healthiness and readiness checks pretty much into it. And if you would just like spin up everything all together in parallel, it might kind of happen that the readiness will be reported sooner than the application actually boots. Or you have to kind of like synchronize everything with like different primitives, which again like makes the code complicated. So why not just like have something which will allow you to actually do it for you and make it simple. So in this case, this diagram as well shows the two things which are quite interesting. So when you're building up the service and when you are tearing down the service, then you have to do it like from different sides, different orders. So when you are building the stuff, you have to like use first build up and spin up and run the things that like everyone is dependent on, right? So like core stuff, and then you can go further and further, and you actually like end up on the top of kind of the hierarchy, where you have the HTTP server or gRPC server running, and it reports its health and so on. But like you have to do it on the very end, right? And everything is kind of like built up and so on. On the other hand, when you are doing the graceful shutdown of the application, which is quite important because like you don't want to lose stuff, right? Like when you lose stuff, you usually piss off someone, like the customer or like old or monitors are going crazy and so on. So we have to do carefully, gracefully, with like very different order. Pretty much like you started from like start to end, and now you have to reverse it. So bring up down like the HTTP client, server, which will kind of stop reporting the healthiness. You can kick even to load balancer to just like remove your pod from actively from the kind of load balancer itself, and then you can just one by one kind of close the services as they want, as you come in the reverse order, and at the end you might close pretty much the most important stuff that you have, right? Like for example, this async publisher. Usually when you are doing like the async publishing using Kafka or whatever, it keeps some state of the unpublished messages in the memory, and you just like want to ensure that everything is published if you are not using like the confirmation. But at least like you don't want to lose anything if you don't need to. So the order matters a lot, pretty much. So what kind of editing problems you might face during like the bootstrapping of any application you can imagine? You have a static part, which is like the dependency assembly. So we have this like many layers, and we have to assemble all together, and like some of the layers might report their like whatever the certificates are corrupted, are not there, files, whatever, you don't have it, and so on. So there's like many things to tackle, and especially when you have like a lot of dependencies in some way, the Go can be pretty bad at it. Then you have the orchestration part, where you have the kind of beautiful graph build up, but you have to run it and close it in the right order, right? Again, like to not lose anything, to just kind of smoothly run it and close it. And then again, you have the testing part, because like this is as well kind of connected. You have like certain kind of methodologies, right? You have unit tests, which are somewhat easier. It's like very tiny, small unit that you have to you can test without any dependency almost, you can mock it, or they are easy. But then when you have like integration tests or closer like to production, end-to-end tests and so on, it might become a trickier. And it's good that if you have something which allows you to reuse the stuff or everything that you use for the production, if you can closely use it for the test, it's as well, because like you are kind of preserving whatever was done for the production. So the testing is very. So the talk actually that I have today is about like the plumber library that we did at Outreach for this exact reason, to kind of allow you to bootstrap the application quickly. There will be a QR code on the end. So what the plumber does for you, it's kind of like manages the dependency tree and in async way, and as well I do the orchestration for you, and helps you do testing with all of that pretty much that was mentioned. Yeah, and I have the mustache because this guy has a long mustache, so it was not about in November or so. I'm ever about the calendar. So the dependency graph. We had kind of like few requirements like for the building up the kind of this thing that would help out with the dependencies. There are quite a bunch of libraries that actually does that, of course, for you. I'm usually like quite picky. And what usually it kind of what we didn't like is that it uses a reflection for one thing, so you don't know like what it does, like so much magic. On the other hand, it might use the cogen, which I actually personally do like a lot, but not in this particular use case, and so on. So we wanted to have something which is like very simple, clear, navigable, so the people can actually like immediately see what is being used, and so on and so forth. We wanted as well like to enforce somehow the structure of the project, so just somehow like make more junior people kind of keep them smooth in the process, and they don't need to think about like much stuff pretty much, and so on. Even I like spend most of the time by like how this variable needs to be named and where it is, right? And then the rest is somewhat easy, but these two things are usually quite demanding. So another thing was that like we wanted the graph to be reusable, as I mentioned, and testable by itself. Why not to have it testable, right? Everything needs to be testable. So when you are bootstrapping the application as well, it was like this sort of screen was on the previous slides, right? We have some package, we have some construction function, which is like beautiful. There are no constructors, so we have this like construction functions. They might or might not return like the receive the arguments. They might not or might return usually like the instance, but as well like the error, right? So it might vary. And then when they receive, like when they return the error, we have to handle it somehow, because like we have the beautiful static checks that kind of like complains about not handled errors. So we have to handle it somehow. So it's easy when you have one, right? Then you have two, which kind of like depends on each other, and you have to like deal with all the errors and so on, which is cool when you have to, but like you have still more and so on and so forth. And then you have like tens of layers, which kind of acts for different purposes. You have the authorization layer, telemetry, authentication layer, all of that stuff. Then it's like quite a mess. Like we have and at one point, like I look at the code, which was like few hundred of lines of code with like these ifs and functions just to make it simpler, and it was just like quite unusable, and you got lost. The few parts were built in like parts, and then they were built again for some reason somewhere else, because like it was so hard to navigate into it and so on. So we just kind of wanted to find something else. So what we do now? So we kind of like enforce the structure in the dependency graph. Like since we are trying to be closer at some components to the hexagonal architecture, which kind of force you to separate the adapters into the kind of specialized containers, let's say, and then use mostly just like the domain models just to talk between them. Then we did kind of the same thing as well for our dependency. So we kind of organized the dependency tree, which you can imagine, as well into kind of like one container, which is like the application, and then the other subcontainers, which kind of reflects the kind of coherent logic that it should be kind of managed by this container. So we have something which is like gRPC, GraphQL, both might have like the gRPC server, which actually physically like accepts the request. You might like kind of manage as well inside the particular the RPC servers for different entities, right, and so on and so forth. The GraphQL kind of like equivalent of it, then we might have some services that provides the controllers behavior and so on. You name it. We can have like the async stuff and so on and so forth. So we kind of build up this tree divided by these groups pretty much, and they can live either separately or they can kind of interact between each other. So I will try to show you like few examples how it actually like look physically, and then I'll show you as well like the result of it. So here we kind of like define the main container, which again consists of like the other containers, and then it's kind of like very simple stuff pretty much, and then we just kind of call this beautiful function which kind of stitches everything all together. But it's using just like generics. It doesn't use any like reflection or so. So you can easily navigate to it. So these containers, subcontainers, are then holding the instances of the thing that you want to build. So we have the service, and we have like two mutators and one querier. The mutator, one is actually doing something else. It's like notifying as well someone when the mutation happens for some reason. Like this as well in the library, everything is like as a whole example of kind of working the application with all of that stuff. So we just like define these instances, and like you can see here that they are just like wrapped with this generic type plumber D, which kind of stands for the dependency, and there is another equivalent which is R, which I'll talk a little bit later. And then, well, these instances are just empty, right? They are like not using reference, but they are like just empty. So you have to somewhat like fill them. Of course, you might use as well some configuration in combination with this library. So how to kind of fill the values into it. The graph, the final graph is abstract, or is like lazily evaluated, let's say. So usually there are some callbacks that you have to implement, but except it's just the constant, right? Usually constant is just the constant, so like we do have constant as well. But then you might want to define as well like instances in like different ways. You might just define it as a lazily loaded kind of construction function that doesn't return the error. So it just like builds up the thing. That's the second most easiest thing. Then you might have it complex, a little bit more complex, which you kind of like define the same thing, but like the construction function can return the error once they are kind of evaluated. And then the third final, kind of like the most complex solution, which actually like this is why we build it. The rest is just there because like it's convenient. When the dependencies or when services kind of like depend on each other, it's like good to know it somehow, right? So the construction is a little bit chatty, let's say, but it gives you quite a lot of value. So here we are like defining the server, and we declare that this server actually like depends on these two dependencies. And once these dependencies are arranged, then like I'm happy to build my instance as well. So the port is always kind of resistance is constant. So we can take the instances out of the graph easily, and then we can finally like build up our kind of final server, let's say. So then you have a graph, but like you should as well use it, right, somehow. So here we just kind of like build up the application, and then we take some instances out of it, either one by one like this, and then you have to again like handle error, which is kind of like but then if you need somehow to use them like in some combination, you can as well like check multiple of these at once, and then you can just like work with it without handling any error, because like it won't have any errors once you check it at once. This is just like one part of it, right? So you have a graph, you have things that might build up on the end, and you might have like ready instances. But again, you have to check the error, and just like doesn't look nice, and it doesn't help with the orchestration part. So we have to tackle the orchestration part. So the plumber defines like few interfaces, which kind of like describes the runnable process. One, which is kind of mandatory, which is the runner, describes that, okay, like I have some function that I can execute, and the function might return the error on the end. But like this function kind of describing the unit of work that needs to be done asynchronously, or like needs to be done somehow. It's supposed to block as well. So like if the thing should be running for eternity, then like it will just like, it's intended to be blocking operation. And then we have like two other kind of optional interfaces that your kind of like process might implement. One is quite interesting. It's readier, which kind of allows you to declare the readiness, right? So you have imagine that you have some cache that needs to load some state from somewhere when on the boot up, on the application boot, right? And then again, you want to first start the cache, make the cache ready, and then you can continue again like with the HTTP server, which declared the healthiness, and so on. So this is something that can asynchronously report the readiness of the process. And then finally, like we have a kind of closable interface, which allows you to gracefully shut down the service. So it's expected when somebody externally call the close, then the run method should at some point stop. So this is just how the interfaces look like. The plumber itself contains as well like primitives, which makes easier to implement these interfaces, because like you don't want to implement everything for all the services as well, for the external services and so on. So the plumber itself has kind of like primitives, which makes it much easier as well, like to kind of model these like processes. But once you have these processes defined, like the workers, let's say, then you can easily run them. And that's as well where the R will be useful. So when we were defining the graph, the D ones were just dependency. So they are just like, that needs to be built. But the R ones needs to comply with the runner interface. So they are meant to be executed. And then therefore you can freely use them in the pipeline as well, just kind of to start the process. So this thing is actually how the main kind of code of the application, of course, if you have any arguments or fancy stuff, might look like, right? It's like very, very, in my eyes, good looking. You can have, of course, like different point of view, but like just again, like build the application, small one, and then like we just start the application. So here, this pipeline defines like serially executed pipeline. So these first two things are started in sequence. So first, this thing needs to report the readiness, then this needs to report the readiness if they are complied with the interface. And then it can jump to this thing, and these two are run and kind of started at once in parallel, pretty much. And then these are interesting things that will done here. So for some reason I kind of reordered it wrongly, but like these two things here, they are like closers. So TTL supposed to close the pipeline within the defined time. So this example will run for 5 seconds, and then the close sequence will be kind of initiated automatically. And then we have a signal closer, which obviously like receive the OS signals and kind of tackles the termination by the OS skills and interrupts and so on and so forth. And then we have these two timeouts, so readiness and post timeout. So for the readiness, we want all the components to report health within like 1 second. Otherwise, the close sequence will be again called. And if the close sequence will not be finished in 5 seconds, then the overall context will be cancelled. Which is quite interesting because like we unfortunately had it in outage as well, that the context is abused for the termination, which is like completely wrong idea. So this thing actually like initiates the close sequence for everything in the right order. So again, like these two will be closed in parallel, and then this thing will be closed, and this thing will be closed. So like they can interact freely, nothing will be lost, so everything will be kind of like nice and smooth. And when it comes to testing, so we have to test it somehow, right? And then we have an environment which might not be that similar with production. You might have some different clients for end-to-end tests, different certificates, whatever, right? You name it. Since the graph is somewhat like lazily initiated, when you actually start it like this, then nothing is initialized yet. So you can supply just like a function which can overrides, makes any override that you can imagine to your graph. So you can, in this case, like lousy example, but we can redefine the port to something else pretty much for the sake of integration test or whatever test it is. So you can manipulate with the graph, but just somehow or slightly, but you can keep the assembly line the same. So like what we had before, like we were kind of assembling the layers at two places, right? When we were testing, and then we actually like bootstrap the application. It brings kind of obvious problems that we did it in different way, and then we were quite surprised like what happened. So this thing will kind of like make the assembly line reusable for tests as well for the production with sort of like customization, let's say. So you can have like just different functions, or you can state, of course, like many of these functions. So you can have something for integration, something for end-to-end tests, and so forth. Usually, like you want to mock some network requests as well in some cases, and so on. And then at the end as well, so this is just like testing that, okay, the port was somewhat overwritten. And the last part is just like asserts that all the instances that are mentioned here are actually resolved and they don't have a problem. So if something is, of course, like the dependency is declared, but the value hasn't been given, or it's like there is no initialization done, it's a complaint that this service requires that dependency and it's like just like not set. Of course, it has like the kind of check for the cyclic dependencies, so it's circular dependencies, so it will just not end up in the infinite loop. Yeah. Oh, we have just like summary, which is kind of like boring. It's super cool. And then yeah, there's this promised article which I'll share later, and just kind of prove that it's somewhat working as well. I fully and you can see. I'll just like share the desktop and hopefully hope for the best that you will see it. Yeah. Okay, you see it. So I have the very same pipeline that I was showing in the code with like hierarchy of things. There is like many services that needs to be stitched together. So when we go to the dependency here, this repository depends on something else, and then the repository might depend on something else, and so on and so forth. So we have this kind of like sequence, and then we just like beautifully done it. And you see that like first thing what it did is just like starting up all the services in the right order. So the dependency, like the database, batching repository start first, the async publisher. And then we might start some like the other runnables in parallel, then it doing some work, artificial work, and then the TTL kicked in and it just pipeline received the shutdown kind of signal. So it was like shutting down again, like reverse order the dependencies again, like in parallel and in serial manner. And finally it got terminated. So luckily we didn't receive any like context timeout or anything, but we kind of closed the service without like any downtime and so on, because like the load balancer was informed. Kind of. And yeah. I'll have no idea actually like where I am, but it is it's over. So thank you for listening. You can finalize scan the QR code. I was told that you will be like distracted if the QR code will be in the middle. So finally, it is.